Welcome back to the deep dive. Now, if you're wrestling with keeping those critical MySQL databases always on, always available, or maybe trying to scale them without getting tangled in complexity, well, you're definitely in the right place today. We're cutting through that noise. This is actually part 2 of our special series on MySQL group replication in a DB cluster. And today we're doing a foundational deep dive into MySQL InnoDB Cluster itself. What is it? What are the key parts? How do they actually work together? Think of this as your essential guide to its architecture.
That's exactly right. We're taking our cues today from some great material over at kedar.inity-witty.com. And yeah, our goal is really to unpack what makes this tech tick, especially for database resilience.
Okay, let's get into it then. So at its heart, what is MySQL InnoDB Cluster? What's the core problem it's solving for, say, DBAs or developers?
Fundamentally, it's a complete package, an integrated solution for MySQL high availability and scalability. Imagine a system that pretty much handles failures automatically, balances the workload, keeps data consistent across servers, all without you constantly needing to step in.
Right, sounds almost too good to be true for anyone who's managed production databases.
It's powerful stuff. It works by orchestrating a few key MySQL technologies together. You've got your MySQL Server instances, of course.
Mm.
Then there's group replication, which is critical. And it's all managed via MySQL Shell's AdminAPI, with MySQL Router handling the application connections. It binds these together.
Okay, so that's the concept. What do you actually need practically to get this system running?
Well, the main things are MySQL Shells. You need that installed. And at least 3 MySQL Server instances running on your hosts. 3 is the minimum for fault tolerance. MySQL Router is technically optional, but honestly highly recommended for connecting your apps smoothly.
And setting up those instances, is that complex?
That's where something called MySQL Clone comes in handy. It's supported, which is great. So instead of, manually copying huge amounts of data when you add a new server to the cluster, MySQL Clone can automate that. A new instance joins and bam, the data gets transferred over. It really helps you scale out much faster, less hassle.
That sounds like a massive time saver. Okay, you mentioned those key technologies working together. Let's break those down. Understanding the roles here seems really important.
Absolutely. These are the pillars, really. So first, the MySQL Server instances. Pretty straightforward. These are your databases holding your actual data. But the magic behind their coordination, their fault tolerance, is group replication.
Group replication, what exactly does that do?
Think of it as the mechanism ensuring that a change made on one server is reliably and consistently applied to all the others in the group. It provides that fault tolerance. If one server goes down, the others carry on, and the data remains consistent. It guarantees data integrity across the cluster.
Okay, so group replication handles the data sync and failure aspect. What about actually managing the cluster itself, setting it up, monitoring it?
Right, that's the job of MySQL Shell, and specifically its AdminAPI. MySQL Shell acts as your command center for the cluster. The admin API within it gives you powerful commands. Programmatic control, really. You can provision the cluster, manage it, check its status, all using JavaScript or Python scripts.
Ah, scripting, so good for automation.
Exactly. It turns complex cluster operations into much simpler, repeatable tasks.
Okay, servers are running, synced by group replication, managed by the shell and admin API. How do my applications actually talk to this cluster without getting confused about which server is which, or what happens if one fails?
Excellent question. That's where MySQL Router fits in. It's this lightweight piece of middleware. It sits between your applications and the actual InnoDB cluster nodes.
Like a traffic cop. Sort of, yeah. A very smart traffic controller for your data map connections. Your app just connects to the router. The router figures out which server is the current primary for writes or which secondaries are available for reads. It handles load balancing. And crucially, if the primary fails, the router automatically redirects traffic to the new primary. Seamless failover, transparent to the application.
And setting up the router.
The admin API can actually bootstrap it for you. It automatically configures the router to know about the cluster members. Makes setup much easier.
Wow. Okay, so bringing it all together, group replication for consistency, admin API for management, router for connectivity.
Yeah.
What does this whole integrated system give you?
Well, because it's built on group replication, you inherit all its goodies, like automatic membership control servers joining or leaving, fault tolerance, like we said, automatic failover. It really aims to reduce those late night emergency calls for DBAs.
Definitely sounds appealing. You mentioned primary servers. Yeah, typically in a DB cluster runs in what's called single primary mode. That means one server accepts writes and the others are read-only replicas. Good for read-heavy workloads. But it's flexible. You can configure it for multi-primary mode where all servers accept writes. That suits different kinds of applications, though it has its own considerations.
That adaptability seems key.
It is. It lets you tailor the setup to your specific needs.
Okay, this really paints a clear picture. MySQL InnoDB Cluster basically bundles these powerful tools, group replication, shell, router, to make high availability and scaling much, much simpler for MySQL users, giving you, hopefully, peace of mind with that data consistency and automatic failover.
Exactly. And maybe the deeper thought here is, how does having this kind of integrated, self-managing system change how we even think about database architecture? Moving from constantly reacting to failures to building in proactive resilience from the start feels like a significant step forward.
It really does. A shift from complex manual processes to automated, self-healing systems. We really hope this deep dive gave you some valuable insights into MySQL InnoDB Cluster's architecture and benefits. And hey, if you did find this valuable, please do like this content. It lets us know we're on the right track. Share it with colleagues, friends, anyone who might benefit from understanding these database technologies better. And of course, subscribe to the deep dive so you don't miss our future explorations into the world of data. Thanks so much for joining us, and we'll catch you on the next one.